Hi class. In this lecture, we're going to move into chapter 6, talking about polynomial functions. And our first lecture today is dealing in section 6.1, which is talking about adding and subtracting polynomial expressions and functions. Now, this section could be a review for many of you from your previous math courses or even from high school. And if not, this is your first introduction to it, that's okay. It's a pretty straightforward concept, but this lecture is a good review even for those who have an understanding of the concepts. Okay, so first off, we're talking about polynomials. So what is a polynomials? Let's define them. So first off, a term is a constant, a variable, or a product of a constant and one or more variables raised to specific powers. Like, for example, 3x raised to the sixth. There's a constant, a variable raised to a power. That's a term. X by itself is a term. A number by itself is a term. Something like x to the 1/2 power is a term, and so on. You can have more than one variable. In this lecture, or in this section, we actually won't deal with fractional exponents, but it's still good to see. So what we call a monomial is a constant, a variable, or a product of a constant and one or more variables raised to counting number powers. Okay, so counting numbers like 1, 2, 3, 4, 5. All right, so a monomial is a single term by itself. So these here, the same ones I have above, except for this one, and changing this term around a little bit, are all monomials. They're just something by itself. Like even -5, x to the 7th power, y to the 4th is just a single term, okay, because there's nothing being added or subtracted to it. So that's a monomial. A polynomial, or what we call a polynomial expression, is a monomial or a sum of monomials. So something like this: 5x to the third minus 2x squared plus 7x minus 4. That's the sum or subtraction of a bunch of different monomials, single terms. Taken as a whole, we call this a polynomial expression. Same with this one, even if there's two variables. Even something by itself, like just an x or a 5, that's a monomial. That still fits into the category of things we call polynomial expressions. So generally what we do is we write polynomials in descending order. So the degree of a term, when I say descending order, it means the highest exponents go first. So the degree of a term is the one variable, is the exponent of the variable. So let me rephrase that. The degree of a term in a single variable, so something like this, because there's only one variable x, the degree of this is the exponent of the variable. So this term right here, like the exponent is 3, this has a degree 3. This here has a degree 2. So something like this, 7x to the 4th, whatever the exponent is, we call that the degree. All right, so the degree of a polynomial expression, so the degree of the polynomial as a whole, is just the highest degree of any non-zero term of the polynomial. So the degree of this expression here, well, we look at the highest exponent. The highest exponent is 5. So we say this polynomial expression, okay, is a degree 5 polynomial. Okay, so let's go through and use words such as a linear, quadratic, cubic, polynomial, degree, one variable, and two variables to describe each of these three expressions, so you can kind of see the terminology. We'll start with something easy and then move into more difficult and more difficult. Okay, the first one here. Minus 3x squared plus 8x minus 4. Well, we look at the leading term, this first term here. The term minus 3x squared has degree 2, which is larger than the degrees of the other term. So this expression is what we call a quadratic, a second degree polynomial in one variable, because there's only the x variable. Looking down here, okay, look at this first term here. The term 5x cubed has degree 3, which is larger than the degrees of the other term. So this expression, whenever we have a degree 3, is called a cubic polynomial, and again, just a single variable, because there's only the x variable. Moving right along into this really crazy complicated one. So this one's confusing because you have two variables. You have an a and a b variable. All right, well, look at the first term, okay? 6a to the 5th, b to the squared has degree 7, okay? So we classify this degree as 7 because when there's two variables, you take the sum of the exponents of the variables. Right, which is larger than the degrees of the other term. Like this would be degree 6. This would actually be degree 5, because when there's a variable by itself, it has an exponent of 1. All right, so we say this is a seventh degree polynomial because that's the highest degree in two variables because we have two variables here, A and B. Okay, so the coefficient of a term is the constant factor of the term, so it's just the constant in front of the variable. So for example, this term, minus 7x cubed, we call the minus 7 the coefficient. So the coefficient is minus 7. All right, so what we define as the leading coefficient of a polynomial is the coefficient of the term with the largest degree. So for example, if we look at 3x cubed plus 6x squared minus 4x minus 9, the term with the largest degree is right here, 3. Right, so we would say this is a cubic or a degree 3 polynomial with a leading coefficient of 3 because that's the value in front of the term with the highest degree. All right, so something like this, 6x to the fifth and 8x squared are what we call unlike terms or not like terms because the exponents of x are different. So if exponents of terms are the same, then we call them like terms, and we can generally combine them. But if the exponents are different, they are unlike terms. All right, so what we want to talk about now is combining like terms. To do this, all you do is you add the coefficients of the terms. So let's do some examples. Suppose you have this polynomial here. Right, when you just look at it, you have 5x cubed minus 4x squared plus 2x cubed minus x squared. I want to rearrange the terms so that everything with an x cubed are adjacent to terms and everything with an x squared are adjacent. So I'm going to move this around a little bit. So I'm going to put all the blue terms, the degree 3 terms together. Excuse me. I'm going to put all the red terms, the degree 2 terms together. So now once you have it here, 5x cubed plus 2x cubed, all you're going to do is you're going to add the coefficients. So this becomes 5 plus 2 gives me 7. Here I have minus 4x squared, minus when there's nothing in front, there's an invisible 1. So minus 4 minus 1 gets me minus 5x squared. And this would be a fully simplified and combined like term polynomial. When we work with polynomials, we always want to do that. Because if you look at this, we want to simplify it into its easiest terms. That's what we want to do with this lecture here. All right, let's talk about this one, a little bit more confusing, where combined like terms when possible. Okay, so here what you have to match up to be a like term is the exponents exactly have to match. So what I see here is I have p cubed t squared, so those are like terms. And p squared t, those are like terms. So I'm going to put them adjacent to each other as such. So now I have 3p cubed plus t squared minus 8p cubed t squared. So 3 minus 8 gets me minus 5. And then 1p squared t plus 7p p squared t, 1 plus 7 gets me 8. Okay. All right, so to add polynomials, all right, basically if you have two different polynomials and you want to add them, all you're going to do is just combine like terms. So suppose I give you this. I want to find the sum of these two polynomials here. 5a squared minus 7ab plus 3b squared. All right, and then I want to add to it a different polynomial, 2a squared minus 4ab minus 9b squared. Well, all I'm going to do is I'm going to recognize where are the like terms. This is a like term with this is a like term with this, and this and this. So I'm going to put them, I'm going to rewrite it so that like terms are adjacent to each other. And then all I'm going to do is I'm going to combine or add the coefficients. So 5 plus 2 gets me 7a squared. Minus 7 minus 4 gets me minus 11ab. And 3 minus 9 gets me minus 6b squared. And now looking at this, there are no longer any like terms, and I've just added these two different polynomials together. Subtracting is a little bit harder. It just involves one extra step. So if I want to find the difference here of this polynomial, 7x squared minus 2x plus 5, minus, then in parentheses, 6x squared minus 4x plus 1, when I go to subtract this, what I have to do is realize that there's a minus 1 in front here, and I have to distribute it to each term. So when I do that, watch what happens. Minus 1, 6x squared gets me minus 6x squared. Minus 1 times minus 4x Negative negative gets me positive 4x, and minus 1 times positive 1 gets me minus 1. Now I see what are the like terms. I'm going to rearrange them so they're adjacent to each other. So now I get 7x squared minus 6x squared. Well, that just gives me 1x squared, or just x squared. Minus 2x plus 4x, that just gets me 2x. And 5 minus 1 just gets me 4. So when you have to subtract polynomials, really all you have to do is just distribute the negative and then combine like terms. Okay, you can verify this in your graphing calculator, meaning if you put in this expression in your graphing calculator and then this expression into your graphing calculator separately, you'll see that they produce the same results. So this is a fully simplified expression. It's good. Okay, so again, to subtract polynomials, first distribute the negative 1 and then combine like terms. That's all you're really doing. Okay, now let's talk about what's called a quadratic function. Okay, we're going to work a lot with this in a later chapter, so it's good to see it here. So a quadratic function is a function whose equation can be put specifically into this form. F of x is equal to ax squared plus bx plus c. And this is where a doesn't equal 0, because if a were to equal 0, you would just get bx plus c, because 0 times x squared would go away. So the a can be any number that's non-zero. And when you're listed in this form, okay, f of x is equal to ax squared plus bx plus c, this is called standard form. Okay, standard form. So the graph of a quadratic function is what we call a parabola. Okay, so a parabola, you might remember from previous math courses, is a graph that looks like a U. Right? So it could be a smile, a right up U, or a frown, a flip down, upside down U. So regardless, the minimum point or maximum point of a parabola, depending on if it's a frown or a smile, is what we call the vertex. And a vertical line that passes through a parabola's vertex is what we call an axis of symmetry. I will show you this. And the part of the parabola that lies to the left of the axis of symmetry is a mere reflection of the part that lies to the right. Okay, so what that means is you could cut the graph in half down the axis of symmetry, fold them over, and they would be mirror images and they would match. All right, so let me show you what I mean by parabolas, a vertex, and an axis of symmetry on this next slide. All right, so this is a parabola that opens upward, okay? So this is this will be a case actually when the value of a is a positive number. So it has a minimum point, the vertex, and we have this line called the axis of symmetry that's not on the graph, it's not part of the graph, it's just describing it, that cuts through it. And this blue line here is the graph of that function, and you could fold them on top of each other and they would match. Similarly, you can have the parabola open downward, the frown that I was talking about. This is when the value of a here is negative. This graph will open downward, and it has a maximum point which occurs at the vertex. So really what the vertex is the vertex is the turning point of the graph. Okay, it's where the graph turns. All right, let me give you this graph here. So I want to find some values from it. So this black graph here is the parabola, okay? And I have some points illustrated on it, okay? So I want to find f of 4. So what you do to find f of 4 is you follow the blue arrow. So the input into the function is 4, right here. So you're going to go up and look where it hits the graph. And the value then of that graph or that function, go over to the y-axis, is 3. Okay? So what this is saying is the input x is equal 4 leads to the output y is equal to 3. So f of 4 is just equal to 3. It's whatever the y value is. All right, let's find x when x is equal to negative 3. Excuse me, let's find x when f of x is equal to negative 3. Okay, so I'm telling you what the output is equal to. I'm telling you that the output is equal to negative 3. So the red arrows show that the output is equal to negative 3. So on the y-axis, I'm going down to negative 3. And what I'm going to do is I have to backwards find the x values. So I'm going to go over until I hit the graph. I'm going to go down. So one possible value here is 6. But I've also noticed that the graph is reflections of each other. So I'm going to go to the other side here to see where the graph also is -3. And I'm going to go down, and I'm going to see that that x value is -2. So the red arrow shows that the output y is equal to -3 originates from two different inputs, -2 and 6. So the values of x here, this has two solutions, are -2 and 6. All right, similarly, let's find x when f of x is equal to 5. So the green arrow here shows that the input y equals 5 originates from a single x value. There's only one point on the graph, and I'm going to go down and find the x value, which is 2. So there is a single input here because this is the vertex. The vertex is a single point here, right? Is the only point on the parabola that is equal to a value of 5. All other y values that are on the graph that are not on the vertex will have two x values, okay? But the vertex will have only a single x value. All right, let's find x then when f of x is equal to 6. But that's weird because there's 1, 2, 3, 4, 5. Here's 6, but there's no graph corresponding to that value 6. So no point of the downward opening parabola is above the vertex, which has a y coordinate of 5. So there is no point on the parabola with f of x equal to 6. You can't find x. It doesn't exist, and that's okay. All right, a cubic function is a function whose equation can be put in this form. All right, so f of x is equal to ax cubed plus bx squared plus cx plus d. So you'll notice that there's just a cubic here, an x to the third power. Again, this is where that leading value a is not equal to 0, because if it was, you would just have the quadratic. All right, so let's just sketch a graph of this to see what it will roughly look like. Just a very simple cubic. F of x is equal to just x cubed. So let's list some input pairs of the function and then plot them correspondingly on the curve. So if you pick some x values like -3, -2, -1, 0, 1, 2, and 3, like -3 cubed is -3 times -3 times -3, which would get you -27, right? Because -3 times -3 is +9, but +9 times -3 gets you back to -27. So you can similarly see how you get all the corresponding values. And when you sketch it, it's going to look like this. All right, some type of downward this way, and then it's going to go up and hit the origin 0, and then shoot up this way. So it's different from a parabola. Like a parabola is a U, okay? This one is not. This one goes all the way down to -infinity, comes up, hits the origin, and then goes all the way up to positive. All right, now let's talk about the sum and difference functions. Okay, it's just another way to talk about adding and subtracting polynomials. But if you have two functions, we'll call the functions f and g of x. Whenever you see the sum function, which is f plus g, okay, so f plus g of x, all you're going to do is you're going to add the first function f of x to the second function g of x. Same with the difference function, f minus g. So if you have f minus g of x, you're just going to take the first function f of x and minus g of x here. That's it. So let's do this. Let's let f of x be the quadratic function 5x squared minus x plus 3, and g of x also be a quadratic function of minus 2x squared plus 9x minus 7. So I want to find the equation of the sum function. So f of x, f plus g of x, you're just going to take the first function and add it to the second function, like so. All you're going to do at this point is align the like terms. And when you do that, 5x squared minus 2x squared gets you 3x squared, minus x plus 9x gets you 8x, and 3 minus 7 gets you minus 4. Now if I want you to find f plus g of 2, well, all you're going to do now, since you know what this function is equal to, is plug 2 in for x here. And when you plug 2 into this function right here, 3 times 2 squared plus 8 times 2 minus 4, Well, that will just simplify to 24 very easily. Let's find the difference function. You follow the same procedure. You're just going to subtract the two functions. But when you do, remember to distribute the -1. All right, and that's going to change the signs of everything to get to the following. So -1 times -2x now becomes positive. -1 times 9x becomes negative, and -1 times -7 becomes positive. And when you combine the like terms, it will just get you this function right here. Now, if I want to find the difference of f and g evaluated at 2, all I'm going to do is plug 2 into this function now. And when you plug 2 into this function, it just simplifies to 18. Okay, so modeling here with the sum and difference. Suppose A and B represent two different quantities, okay? And I'll do an example where they represent two quantities next. Then A plus B represents the sum of the two quantities, and the difference A minus B tells us how much there is of one quantity, how much more there is of one quantity than the other quantity. All right, so if a difference A minus B is positive, then A is more than B. If a difference A minus B is negative, obviously then A is less than B. All right, let's work through one example of this. Okay, so using a sum function and a different function to model a specific situation. So men's and women's enrollment at U.S. colleges and universities are shown in a table on the next slide for various years. The enrollments in millions of students of W, T, and M of T for women and men respectively are modeled by the system below, where T is years since 2000. All right, so what this is saying is, look, the number of women enrolled in U.S. colleges at T years since 2010 is given by this function here, minus 0.0071t squared minus 0.141t plus 12.05. For men, very similarly, it's minus 0.0071t squared minus 0.012t plus 9.01. All right, and this equation is all I'm saying is model the enrollment here, all right, since the year 2010 of women in colleges and men in colleges. Okay, that's it. That's all it does. First thing you should notice is that women enrollment, these values are correct, is actually much larger than men's enrollment in college. Okay, so let's do the following. Let's find an equation of the sum of enrollment of women plus men, perform a unit analysis of the expression, find W plus M of 11. What does it mean in this situation? Find an equation for the difference, and find W minus M of 11. And what does it mean in this situation? All right, so first off, the sum. All I'm going to do with the sum is take the two different functions that I have for women's enrollment at T years since 2010 and men's enrollment at T years since 2010 and add them together. So when I add the two functions together, I simply get this right here. All right. So for the expression, the unit analysis, we have millions of females plus millions of males. So the units of the expression just are millions of students. So whatever number I come up with, if it comes up to be like 10, that means there's 10 million students. So if I want to find plugging in 11 into my sum here, well, I plug 11 into that function I just found, and it's roughly equivalent to, if you plug this into your calculator, 17.56. Okay, well, what does that mean? This means the total enrollment for women and men in, well, that was T is years since 2010, so this is the year 2021, will be about 17.6 million students, according to this model. That's what this is saying. Let's find the difference function now. So just subtract the two. All right. When you do subtract this, all right, don't forget to distribute the negative. All right. You're going to get the following. So you're going to get minus 12.2t. This squared is an error. Sorry about that. This and this cancel. It just should be minus 0.12t plus 3.04. Sorry about that squared there. That's incorrect. So plugging in 11 into this, all right, you get the following number, 1.72. Well, this means in 2021, women's enrollment will exceed men's enrollment by about 1.7 million students, according to this model. All right, thanks, class.